Hey friends, welcome back to the channel. In today's discussion, I would like to cover what is RAG, what is Retrieval Augmented Generation. And I got this idea from the earlier this week, a conversation with the developers and solution architects who were trying to understand what RAG was. They were asking me, hey, what is RAG? How does that actually work? What specifically types of scenarios would you want to use RAG in? And I figured to make this video so more of you folks can benefit from it. So today we can talk about a few topics. We'll talk about what is RAG. We'll then dive specifically into how does it work. We want to understand the underlying mechanics around what makes RAG possible. What are the components involved aside from some sort of a language model. And then third point I'd like to cover is to show you how you can very, very easily build RAG, start familiarizing with it, and implement it yourself very, very easily with the Amazon Bedrock service. So let's dive in. Let's talk about what is RAG. Now, we can see here directly on this page, which I'll share all the references in the description of the video that we'll walk through today, so you'll have ability to revisit any of these. If you take a look at just the name itself for RAG, what does it actually tell us? It has retrieval augmented generation. So we know for now, just forget about retrieval and augmented, just think about generation. That is what the large language models do. They generate text. Now with RAG, you have ability to augment, to change, modify how they generate or what text they generate based on some of the information that can be first retrieved from some sort of a knowledge base that contains the information about the more recent events, the events that have transpired after the model has been trained. Now, this page will walk you through the details of what is RAG in a bit more depth and what types of scenarios it can be used in, why is it used. It's used, you can see here, to ensure that the LLMs do not present false information, make sure that they do not hallucinate. And also it's going to help with some of the out-of-date text that is being generated by LLMs simply due to the LLM not having the latest information. And that is in fact, those are in fact 2 points, 2 main reasons that RAG was created and invented in the first place, to combat hallucinations or scenarios where LLMs make up stuff that no one told them, they haven't learned from anywhere, they just make it up because they do not want to say potentially that they do not know the answer. And then the second reason being that sometimes they will have the information, but that information will be outdated. So we want to make sure when LLM responds to a prompt that it's responding with the most recent, most relevant information. Now, further down this page, there is a really nice graph or a really nice diagram that tries to illustrate what the RAG does and how does it work. So let's take a look at this simplified version first, which I pulled up in a separate tab for us, and then we're going to dive a little bit deeper and talk about what is behind some of these boxes. So we can see here that this is potentially going to be some sort of a client. It could be your laptop, some sort of a client that is going to receive the prompt sent from the user. And then that prompt, instead of being sent directly to the LLM, instead is going to be sent to some sort of a mechanism, and we'll talk about here shortly how this works, some sort of mechanism that's going to have a goal of looking up similar information in a set of knowledge bases that it has access to. So if I were going to ask you let's say that your knowledge stops, you're an LLM, and your knowledge stops at the end of 2023, year 2023. And my question to you is, hey, what did this company release as a product in second part of 2024? how are you gonna know? You're not gonna know because your knowledge stops at the end of 2023. But hey, maybe some knowledge bases here nearby, some repositories of documents can have relevant information that can be combined with the user's input. So what the LLM receives is both the user's input as well as that relevant information. And then LLMs are great at parsing through text and understanding what the text is, what information it's including. So it's going to see the prompt, it's going to see the relevant text, relevant context, and from that relevant context, it's going to be able to find what the information it needs in order to answer the user's query. Now, as I mentioned earlier, this is a very, very simplified diagram that just shows a box that says search relevant information. But what does that actually mean? So let's take a step below this representation and talk about a little bit more of a greater detail here. So what typically happens with the text generation use cases is that the user is going to ask some sort of a question. And let's say that you have some sort of a model that was trained, or its knowledge base or its internal knowledge base it goes up until early 2024. And let's say that this user is just like me, you were interested in tech and this space. So the user is looking to understand some of the questions around, hey, what are the most notable aspects of Llama 3.3 model? Or what are most notable aspects of DeepSeek R1 model? What are the differences between the two? And by the way, if you're interested in the DeepSeek R1 model and how it can be very easily hosted in a few different ways on AWS, make sure you check out the one of the previous videos where I created, actually it was the first video I created on this channel when I started to I gave it a shot earlier this month to start creating some of these educational, helpful videos. So if that interests you, make sure you check it out. It has some really nice demos and walkthroughs there as well. Now, here with this text generation workflow, we already see this is not going to work because what the user is asking about are some questions that require the model to have very, very recent knowledge. Llama 3.3 model was released at the end of 2024, and then DeepSeek R1 model was released in January of 2025. So this LLM, this large language model, whose internal knowledge stops in the early 2024, is either going to try and make something up that we can't rely on, that we can't trust, or it's just going to say, I have no idea what you're talking about. This stuff, you're making stuff up. This stuff does not exist. So instead of having this very, very simple text generation workflow, what we're going to do is we're going to augment it with some retrieval. See? That's where retrieval augmented generation comes in. So we're going to instead send the user's input through some sort of an embedding model so that we can convert the user's prompt, the user's question, into embeddings into the vector space that is very, very efficient to search through. So eventually what you end up with here is some sort of an embedding, some sort of a vector space representation of the user's question, of the user's prompt. They can then be compared to some of the vectors that we have, some of the embeddings that we have in our vector store. And practically with this semantic search, when you're searching for something similar, we can very, very efficiently find how close the vector representation of the user's question is to different vector representations for different information within the vector store. And that is going to allow us through this similarity search to retrieve some relevant context, maybe context from the recent blog posts, context from some of the documents that have been uploaded, research papers, and then you combine that through that context augmentation process. You combine the user's input with that relevant context. So in a way, it's kind of like cheating because what the LLM really receives is going to be that question from the user, and then also some chunk of text that includes somewhere within the text includes what the answers to the user's question could be. And then the LLM has very, very easy time navigating through that text and extracting the relevant information that's relevant to the user's query, and then returning the response to the user. So that will then enable, in this case, if we load it into our vector store, various websites that we crawled, various documents, research papers about these two more recent LLMs, and the context that the model receives is going to include various text chunks that include that information, and it's going to be able to say, okay, let's take a look at step number one. What is the user asking about? It's asking about, let's say, what are some of the differences between Llama 3.3 and DeepSeek R1. It's going to say, okay, let's take a look at the context here as part of step number two. I'm going to, as part of context, have some text snippets that talk about Llama 3.3 and DeepSeek R1, parse through that, figure out what the differences are within those text chunks that were provided, and then return a response back to the user there. Now, the next question that comes to mind, now that we understand how the LLM is able to answer the prompts that are about the knowledge that the LLM itself doesn't have. The next question comes to mind, okay, but how does what actually gets to this vector store, and how does it get there? And this is where we start talking about the second part, the second workflow that you typically have within RAG, which is we sometimes refer to data hydration workflow, where you are refreshing the relevant data, in this case, in this vector store. So how would you potentially go about doing that? Well, you would have some sort of a flow where you have various data that this can be, again, residing in your organization. It can be residing in different SaaS products, residing on the websites that you can crawl, and then you're going to load that in some sort of a document repository or document store. And then from there on, we have ability to use the embedding model, which, by the way, has to be the same embedding model as what we use during the text generation workflow to embed the user's query. Use the same embedding model to generate the embeddings of those chunks of documents that are being loaded from the document store. So that then produces a set of embeddings that can be loaded into this vector store. And that ensures that during the text generation workflow, you have the relevant context, the relevant embeddings already in the vector store for the text generation workflow to be able to find the similar information there. And as we can see here, the text generation workflow we oftentimes refer to as the online workflow, because that happens in real time during the client's request, while the data hydration workflow we refer to as the offline workflow, because you can do that ahead of time. That can be a batch process, and it can be a very cost-effective way of loading the data in, instead of having to go through the complexities of setting up streaming and real-time experience there. Now, finally, the last question that comes to mind is, okay, once that relevant context is found in this vector store, let's say some of the embeddings like this will be found to be similar to the embeddings of the user's input. Do you then convert from embeddings back to the text representation, like the way it the way it appeared in the document store? And the answer is no, you don't do that. You just practically have a mapping between, hey, this particular embedding is going to have some sort of an ID, and this particular mapping is going to map to the same ID of a particular document within the document store. And then you're going to have the next embedding that maps to a different document chunk there. So when you find the most relevant embeddings, you're not converting embeddings back to text. Instead, you just, through that mapping, say, okay, so this is the document chunk. Let's include that. Let's pull that document chunk and store that, provide that as part of the relevant context. So hopefully this kind of helps you demystify a little bit, understand a little bit beyond those more simplified representation of RAG, what is actually happening there behind the scenes. Now, this, to me, is really interesting use case where you are asking the LLM to help you understand some of the similarities, differences, provide different information about different large language models. And in this case, we are, as we said earlier, interested in Llama 3.3 model, which was released at the end of 2024, and then DeepSeek R1 model, which was released in January of 2025. So they're practically almost all LLMs out there are going to be unaware of this just simply due to it being such a recent event. So let's take a look at an example. Why don't we go through some examples of how we can confirm that the LLM does not have this information or it's hallucinating, and then how we can implement RAG very easily through Bedrock service. So let's head there. And let's take a look at let's go to, in the management console, we're going to go to the playground for chat or text, where we can easily interact with the different language models. And we're going to select a particular model. I'm going to select from Anthropic here, one of their best smaller models available that's very fast and very low cost, which is Claude 3.5 Haiku. So let's select that LLM, and let's close this sidebar. We're not going to need it. And let's ask it some questions. So let's ask it what are most notable aspects of Llama 3.3 models, because there's multiple models. So let's submit this, and it's going to say, I want to be direct with you. While I'm aware of Llama models, I do not have confirmed details about a specific Llama 3.3 release. I can discuss Llama 3, which was released by Meta in April 2024, but specifically about 3.3 version, we're required to verify current information there. So this kind of tells you that this model, at least based on this response, potentially maybe has knowledge until going up to at least April 2024. But again, unless the model is sharing some very specific information about your prompt, you can't really believe these types of claims. So let's clear this up. We can see that it doesn't know about Llama 3.3. Let's clear this up, and let's ask it what are most notable aspects of DeepSeek R1. And let's submit this. Then it's saying, I apologize, but I cannot find reliable information about a specific AI model called DeepSeek R1. DeepSeek is a known AI research company that has released language models, but I'm not certain about models, specifically R1. And DeepSeek has been around for some time. Just this model R1 is a very recent information there. So finally, we could ask it, hey, what are the differences between these two? But obviously, it doesn't know about either of them, so it's not going to be able to map out a difference. We could still ask it just so we can see if it's potentially going to hallucinate. So we can say, what are some differences between Llama 3.3 and DeepSeek R1? And let's see what it says. And yeah, this is, to Anthropic's credit, their models are pretty good at out of the box being unlikely to hallucinate in most scenarios. So you can see the model is just saying that it doesn't know. It's not trying to make up some answer just to provide us with an answer. It just says, I don't know. That's oftentimes that is actually every time much better type of a response than saying that, making something up, all right, something that is not true, which we refer to as the hallucination. Okay, fine. So how do we solve for this? The way we like to solve for this is by creating what's called the knowledge base on Bedrock. So let's go expand the sidebar for Bedrock. We're going to go to scroll down to the builder tools, and we're going to select knowledge base. By the way, if you're interested in some of these other features like agents, flows, prompt management, just drop a comment and let me know what you're interested in, and then in the future I'll try and create potentially a walkthrough of how those features work and what you can do with them as well. So we selected the knowledge base. I'm going to again hide this to optimize our space here. And I have two knowledge bases, but neither of these two knowledge bases are for this use case that we're right now reviewing. So I'm going to go ahead and create a new knowledge base. Now, when you create knowledge bases, you can create it with the vector store, which maps to a variety of different types of vector stores like OpenSearch Serverless. You can create a knowledge base with structured data store, which uses Amazon Redshift, the petabyte scale data warehouse behind the scenes. Or you can create the knowledge base with the Kendra Gen AI index, which is utilizing the search and indexing capabilities of Kendra service there. So we're going to go with the vector store, which is the most common use case. And let's name this knowledge base something relevant. So we're going to say the name of this knowledge base is LLM news as an example, right? Because we're going to have the most recent information about different LLMs. We can provide the description. I'm not going to do that. We can skip it. We're going to create and use a new role just for simplicity purposes to allow this knowledge base to have their necessary permissions to pull in the relevant information. Now, when it comes to the data sources, there are many data sources we can choose from. S3 is the most popular one because that is where the most of the data comes from in these types of scenarios. According to the blog post published by our CTO about a little bit less than 2 years ago, there was back then in July of 2023, more than 280 trillion objects across entirety of AWS in S3 service. So that kind of tells there's a huge amount of information in S3 and why it's most often the source for these types of ML and data analytics use cases. There's a variety of other applications that can be sources as well, but I'm going to select the one that's in preview currently for web crawls, where I have ability to specify various web pages, and the web crawler is going to go out and crawl those different pages to collect information there, and then take it's going to, once the information is there, it's going to be able to load that information, chunk it up, generate embeddings, and load it into a vector store. So let's go with the web crawler option and let's see how this plays out. I'm gonna say next. It's going to ask us for the data source name. I'm going to keep this default name because we're going to now be providing the source URLs. So what are some URLs that could be beneficial in this type of a use case? Well, I picked out a few from DeepSeek and a few from Meta about the Llama models. So we're going to select the DeepSeek R1 release page, which has a variety of information and graphs, has images as well around what DeepSeek is, how does it work, how does it compare to other models, and so on and so forth. So that's what I'm going to provide as the first source. So let's go add that as the first source. I'm going to say add source URL. Let's add another one. And I'm going to add this from xArchive, DeepSeek R1 incentivizing reasoning capability in LLMs with reinforcement learning. So let's go with that. I'm going to choose the HTML option. So we can easily crawl that instead of downloading a PDF, which I will need to store in S3. So let's go ahead and include that source as well. I'm also going to add another source, and there is another source here, another paper, brief analysis of DeepSeek R1 and its implications for generative AI. So let's grab the HTML page of that as well, and let's add that as a source as well. So that should be plenty of information on DeepSeek. Now, next, we're going to add a few more sources for Llama as well. So there's a blog post titled "The Future of AI Built with Llama," released in December of 2024, shortly after Llama 3.3 was released, which references the usage and the different aspects of Llama 3.3 70B right here. So we're going to include that is the first Llama source, and we're going to add another paper, the Llama 3 herd of models, that was published in July of 2024, which talks about Llama models. So that may be interesting for us to include. And in this case, we maybe we can skip this because I don't see the option to use the HTML format. So let's see, PDF source. Yeah, I'm actually going to skip this just because I prefer not to have to go through the S3 paths. We could have done that, but again, it's just going to be quicker to skip that. So let's skip that and let's go to the model card for Llama 3.3 instead. So this model card, where you can also find their rest of their Matos Llama models, you'll find various information about Llama 3.3 model and what it can do, how does it compare, how does it work, how is it trained, what data was used, and so on and so forth. So we're going to also try to crawl this as well. So we've added this as the fifth reference. That's plenty for now. Now you could configure other settings around the security if you want the data to be automatically deleted if you end up deleting the knowledge base. And then also if you want to use your own encryption key with key management service to encrypt. I'm going to use the default options there. Now, when it comes to the syncing scope, we have an option to scope, to use the default option, which is going to practically just scope, as a scope, use that domain and in any underlying pages as well. So an example to include here is if your source is AWS Amazon.com Bedrock, it will go down to Bedrock agents if there's such a page, but some of the other sibling URLs like Amazon.com EC2, right? They're not under that page or not going to be scanned. So that works in this use case. That's what I'm going to go with. The maximum throttling of crawling speeds, I'm going to keep this at 300 here. You can choose the regular expression patterns that will include or exclude different aspects there. And then when it comes to the chunking, you can choose if you want to use the Bedrock default parser, which is great if you're processing only text. In this case, you saw some of those sources also have some images and some graphs, so I like actually to include that as well. So I'm going to use the foundation model as a parser, and there are a few options here. So I'll use the 3.5 Sonnet as the foundation model parser. So aside from the text, we can also parse through the images and capture that information as well. You can modify the system prompt for the instructions for the parser. This is the default explaining what needs to be done, like extract the content from an image, page, and output in markdown syntax, and so on and so forth. We're going to keep the default here. That should work just fine. You can also choose the chunking strategy. This is going to drive the decision around how is the content being split into smaller chunks and how does that eventually then get loaded to the vector store once it's embedded. So we're going to keep the default chunking strategy, but there's a variety of other options included. And then you can also specify your own Lambda function where you can chunk whichever way you want, right? Implement your own chunking logic, which is something I'm not going to do right here, right now. So let's select next. And this is where you got to select the embedding model, which is going to be taking the text chunks and converting them to embeddings. So for that, I'm going to say select model. And I'm going to, let's maybe use the, from Cohere, let's use embed English v3 as an option. So this foundation model is going to, or this embeddings model is going to be responsible for taking in the chunks of text produced through that chunking strategy we just configured and generating the embeddings, just like you saw in the more detailed view of RAG, where we had some sort of an embedding model that was generating the embeddings from the text chunks, and then that's going to get loaded into the vector store, which is something we got to configure next. So when it comes to the vector store, you can take the quick creation vector path, which allows you to choose OpenSearch Serverless or Neptune Analytics for graph RAG use cases, or you can be a bit more explicit with choosing and configuring other options like Aurora with Postgres SQL compatibility and the PG vector extension that enables Postgres SQL to operate as a vector store. We can choose MongoDB Atlas, Pinecone, Redis, or again, Amazon Neptune Analytics. So I'm going to go with the just a quick create new vector store so we can quickly be done with this. And then we got to specify the S3 path where some of the information is going to be stored as part of this process. So I'm going to say browse. I'm going to find one S3 bucket here, and let's go with this S3 bucket as an example. So I'm going to choose next, and with this we get the review of all of these settings that we just configured. Just one final check to make sure that we've configured everything correctly. I believe that we have. So let's go ahead and say create the knowledge base. So at this point in time, a few things are happening. At this point in time, the key component which is going to take the longest to have created is going to be that vector store, which is running on OpenSearch serverless. Now, being a serverless database, it's going to be very easy to host, and you're not going to have to worry about infrastructure scaling and patching and so on. But still, as a database, it's going to take some time to create. So be ready for this step to take, which is typical for databases, 15 to 20 minutes to be created. And then once that is created, by then all the other dependencies will be in place, and we should be able to start syncing that knowledge base and crawling all those sources that we configured. All right, this process was actually much faster than I anticipated. It honestly completed in about 2 to 3 minutes. So OpenSearch serverless does spin up incredibly fast. Now, once the knowledge base has been created, you'll get this type of confirmation, and we can actually go directly to OpenSearch service and just confirm that the database has been created there. So let's search for OpenSearch, and I'm going to open this in a new tab. So let's go there and let's find the collections. So collections is going to show us all the OpenSearch collections that exist. And we can see this is the one that was created today, just now, a few moments ago. And you can see right now it's 2:52 p.m. Eastern time on my clock. And this shows 2:49 here. So yeah, honestly, it took just about 2 minutes to create this very quick. So we can take a look at the knowledge base, or this vector store, which is going to be sitting behind the knowledge base, and it will show you all the configurations and the endpoint being used and so on and so forth. Now, the good news here is that you don't have to worry about these endpoints. You don't have to worry about interacting with OpenSearch at all. You can just interact with that knowledge base you created in Bedrock, and then Bedrock takes care of the rest of propagating those requests to wherever they need to go. So at this point in time, we have the knowledge base created, and I'm going to just minimize some things here. We can see that it has that one source. We could have created multiple sources, but at this point in time, we have just that one source. And if we again open up the source, we'll be able to see what the sync history looks like. Now, at this point in time, you can see that there is no syncs, right? Because we just created the knowledge base. Now, the next step is to go out to those data sources and be able to start to pull in the information from them, start crawling those websites, and then work on loading the knowledge base using the parsing strategy with the Claude 3.5 Sonnet V2. V1 in order to capture the image information as well. Then we're going to start loading the information in. So let's go ahead and click on sync. That is going to kick off the sync process. And then this process is potentially going to take some time because there's a variety of websites that need to be synced and then or crawled. And then once they've been crawled, we're going to have the process automatically be done of converting the crawled information, chunking into smaller chunks, and converting that information using that Cohere English V3 model that we selected earlier to create the embeddings. So I'm going to give it a few moments here to finish the syncing process, and then once the sync is complete, we're going to go in and see how we can use the knowledge base. All right, it looks like the syncing process has been completed. So at this point in time, we should have all the relevant information, and we should be able to just go in and start testing immediately. Now, to test with the knowledge base very easily, you can utilize this view here on the side where it says select the model. This is going to use the knowledge base we just synced, and it's going to allow us to test a particular model with the knowledge base. So let's see, let's try and test out exact same model we used previously. I'm going to say Anthropic and choose Claude 3.5 Haiku, exact same model we used previously. Apply that. And then I'm looking to choose the configure retrieval and responses, customize search to your knowledge base, select the configuration icon. Okay, let's say select the configuration icon and let's close this so we have a little bit more space here. So let's try to, again, select the model and say Anthropic, Claude 3.5 Haiku. That's what we're going to apply here. And there's a variety of configurations here. It looks like it's telling us that one or more data sources have not been synced just yet. So let's go in and take a look at that. It potentially may not be ready just yet to test. So we see that we have that one data source, and let's open it up so we can see the sync process for the data source. And let's see. Okay, it says complete, but it looks like it has some warnings here, and it's completed 411 files. It looks like it failed to sync 6 files here. Now the reason, and we can find more information in the logs there if we say view warnings. Let's take a look. It looks like it skipped the GitHub documents here, and those were. It looks like mostly as it was focusing on that final document that we shared that was in GitHub model card. It looks like it went beyond what we asked it to do. It went to Quen and it went to some of the other elements here. So it looks like what it synced was what we wanted. It's just that as it went beyond that, it ran into various challenges there. So let's go ahead and let's select the shouldn't impact us negatively, because what it had issues with, what it had to skip, was something that we didn't really want to be parsed anyways. So let's say select model here and choose the Anthropic 3.5 Haiku. And let's ask it some questions. So we're going to ask it the same question as before. So let's do what are most notable aspects of Llama 3.3. And let's ask it that question. And it says it's having some issues with the on-demand throughput that is not supported for this model here. So it looks like we have to purchase potentially the provision throughput for this. That is something that I don't currently have. So let's try and select a different model here. The Claude 3.5 Sonnet V1 should be having the knowledge base be around the same as Claude 3.5 Haiku, because those two were kind of released at the same time there. So let's say apply here, and let's try using 3.5 Sonnet instead. So let's say what are most notable aspects of Llama 3.3. And let's see what it says. So it's going to say 3.3 is a multilingual large language model, and then it just keeps generating on and on and on. So let's see what it says. Developed by Meta with several notable aspects. Then it says, first one, improved performance, Llama 3.3 70p instruct model, and that is actually correct. It is a 70 billion parameter. We can see that in the one of these texts right here, where it says Llama 3.3 does have 70 billion parameters there. So we also can see and confirm that the information being shared is accurate. And then it talks about the various other points around what makes this unique. Now, when you use knowledge base, you also get references here. So we can see which chunks of information did the knowledge base use to provide the LLM with the relevant information. So we can click on any of these chunks and we'll be able to see exactly where it was pulled from. So that last source that I added, that was the model card for Llama 3.3. It looks like that was one of the chunks. It came from there. The second chunk also came from the same document. Third chunk, same document. for chunk. Okay, so the model car basically provided all the information that the model needed and had the most relevant information, which I agree is correct, because this blog post, the first source that we included, was really focusing on various Llama models, not just 3.3, and it had very little information on Llama 3.3 model, while the model card here that came from GitHub had quite a bit of information: how was it trained, where it came from, the number of parameters being used, and how was it fine-tuned for safety, and so on. So we can do the similar test with DeepSeek, and we can say what are most notable. And actually, before we do that, let's clear this. So there's no earlier context being included to the model. So what are most notable aspects of DeepSeek R1? And in a similar fashion to our test with Llama, we should be able to get the information being shared here about DeepSeek that also has references there as well. So let's take a look at some of the beginning of the response. Demonstrates impressive performance across various benchmarks and tasks. Some of its most notable aspects include strong performance on education-oriented knowledge benchmarks. And then it talks about so on and on and on, how it compares across the benchmarks with other models, including the OpenAI's O1 as well. If we take a look at the references here, it looks like from this archive paper, the comparison between DeepSeek R1 and other representative models, that was the one source. And it looks like another source came from a different paper in archive. And it looks like the archive included those research papers, included all the information that was necessary. Now, we can also ask it, and there's more references here near the end for some other information that the model has included in the response. Now, with this, we can also ask it some details around how many parameters does DeepSeek have. So we can say how many parameters, let's just be specific, model parameters does DeepSeek R1 have? All right, it's gonna, again, try and find the relevant information and come back. Now it's saying it's too many requests, right? Because I'm using just on-demand capacity. If I purchase the provision throughput, I would have guaranteed capacity. But when I use on-demand capacity, I'm practically just using whatever's available there. And during certain more strenuous periods of time, there may not be as much on-demand capacity. But provision throughput would alleviate some of these concerns around the insufficient capacity. So let's try again. Let's try again and see if it goes through now, if there's sufficient capacity for the model now. And if you'd like me to create another video, another discussion around how the capacity allocation work with what are the different options, and it looks like the request is too high again with the frequency requests with the configurations I have in my account. But we can go on and keep conversing with the model now, because now it's more reliable. It has more reliable information there. So there you have it. You heard what the RAG is. We discussed in a bit more depth what are the mechanics behind RAG, and then we also saw an example of a walkthrough how to set it up, what are the components that you set up behind the scenes. And the beauty of knowledge bases on Bedrock is that it simplifies that whole process, because you saw behind the scenes you have a vector store, you have some embedding model, you have for particular chunking process, you have another large language model. When it comes to that data hydration workflow, there's some sort of an ETL process running behind the scenes that's crawling the websites and chunking the data and converting it to embeddings, loading into the vector store, and during the text generation workflow, that vector store is being effectively used to perform similarity search between the user's input and all the contents in the vector store. So knowledge base really abstracts all that away, and it just allows you to say, I want to use this LLM with the knowledge base, and then you don't worry about anything else. Everything else is handled by the service there itself. Now, if you'd like to learn a little bit more about RAG, dive in a little deeper on your own, there's some great free courses. They're available. They're all going to be free. There's no cost to exploring them. And the first one that I'll include in the description of the video is how to build RAG workflows with the OpenSearch service. So if you want to replicate some of the things that I've done, there's going to be some discussion here around how to do that. It's about 60 minutes of your time. Another great option is optimizing foundation models course, which again takes about 1 hour, and it's also free. And this is going to kind of compare the RAG with fine tuning and talk about when you would want to use each. So step a bit outside of RAG there. If you're looking to dive even deeper into fine tuning RAG and overall understanding of how the MLOps gets extended to large language models, because there's some unique requirements that exist there, you can check out this LLMOps class, that course that I recorded. There's less than 90 minutes, but it's rounded up here, about 90 minutes of content, and I go through a variety of sections where I talk to you about what does the whole Gen AI architecture typically look like, how do you select models, how do you improve the performance, how do you evaluate the LLMs, what tools we use for that, and then there's a variety of other topics included there as well. And then finally, this building Gen AI apps using Bedrock course is also being free, is perhaps the most time-consuming option that's going to allow you to dive the deepest, and depending on how much time you have, it says here it's about 6 hours of content, but you can be a bit more selective there. And you can see this was recently updated. It was updated in the January 28th of 2025, so less than a month ago, to ensure that the course has the most recent information. And you can see in this course, you'll step outside of the working with LLMs directly and explore some of the other options, like using LangChain to integrate with the LLMs. With that, hope that you enjoyed this walkthrough, and I'll catch you in the next one.